When it comes to calculating an area of an octagon, you often come across a formula that has a number in it, a 4.8 or a 4.828, something along those lines. In this video, I'll explain what is the meaning of this 4.828 and where does it come from. To use the formula, you just need to memorize this number, but this number is inaccurate. There's a better way to calculate an area of an octagon, or there's a better way to work with this 4.828 number, unless you like memorizing meaningless numbers. I'm going to show you in this video how we arrive to this number and what its actual digits are. Like I said, it's a close approximation, but it's got some inaccuracies. So this formula would require you to calculate the area of an octagon. If the octagon has a side length of, say, 5, that would mean that you need to square the side length of the octagon and multiply it by the 4.828. If you do so, you're going to get 5 by 5 is 25, multiplied by 4.828 equals 120.7. Let's see, how do we do this? There, you can see it. 120.7. So I'm going to just record that one. That is. And now from this video I'm going to leave out units of measurement. That 5 can be centimeters, miles, millimeters, inches, whatever you like, and that's going to be square millimeters or inches squared, whatever else. Don't worry about it. It's a distractor for a unit of measurement. I'm just going to go with the numbers. Watch the numbers and watch the shapes. This is going to be a little bit involved, but it's good for your brain. So another way to calculate the area of an octagon, other than that formula there, is to slice and dice into different shapes. For example, you might want to chop it into 2 trapezoids and a rectangle in the middle. And that works fine, because the formula for the trapezoids is also a well-known one. You have to take the longer base and the shorter base, add them together, chop them in half, just to average them out, and then you have to multiply it by the height of the trapezoid. And the shorter base here is 5, and the longer base here is unknown. That 5 is not good here. Oops, where is the eraser? No. There we go. Yeah, that's not 5. Okay, that's 5, that's 5, that's 5, and all of the sides along the perimeter of the octagon are 5. We don't have the base because it needs to be calculated. If you want to calculate the base of this trapezoid, you're going to have to split these 2 triangles off the ends of the trapezoid. It's an equilateral triangle. It's going to be a 45, 45, 90 triangle where 5 is the hypotenuse, and then you're going to have to do trigonometry with this 45, 45, 90 triangle, and to get the height, or this little end portion here, either which way, you have 2 of those, and then you have to add and get the area of the trapezoid, and then you have to calculate the rectangle. So instead of calculating different shapes, all different ones, how about just calculate one shape, triangle, and just multiply it by 8, because we have 8 of them in an octagon. The previous one also works with trapezoids, but I think this is going to be a little more straightforward, that's all. Both of them are equally valid. So here is the same octagon with the side length of 5, and I'm going to work with one of the triangles, just one shape. The area of a triangle is calculated by a very simple formula: base times height divided by 2. You're done. And then just multiply it by 8, like I said. Now, I made some changes here to the lettering. Here, what is the side length of the octagon? 5. It becomes the base of the triangle here. Not because we do some magic here, but that's how the same numbers, the same quantities relate to different shapes. So it's called side length here and it's called base length there. Either way it's the same thing, it's just different shapes have different terminology, that's all. And this triangle is nice, but we need to calculate the height of it again, and to calculate the height of it you need a right angle triangle, because the trigonometric functions relate to right angle triangles. You know those sine, cosine, tangent nightmare? That's gonna work only with right angle triangles. So instead of 8 of these, we're gonna have 16 of these. And also please do notice that what used to be 5 for base, now the new base on the smaller triangle, that's half of this original triangle, now is half of the original side length or base length. Instead of 5, now we have 2.5. Same height throughout, same height. But this is what we can calculate with trigonometric functions. And the trigonometric function I'm going to pick is the tangent function. And I renamed the sides yet again. Now I made here, do notice, it's a TIE fighter here out of this octagon. We have a pizza in the middle with 8 slices. The numbers are small, but stuff is numbered. The pizza slices are there. And because there are 360 degrees in a circle, each slice is a 45-degree angle. We need, for the trigonometric functions to work to calculate the height of the triangle, we need an angle. We need the angle to calculate the height. We need the height to calculate the area of a triangle to get the area of the octagon. It's involved, but you can do this. So I renamed the sides of the triangle yet again, because the trigonometric functions talk about opposite, adjacent and hypotenuse. So first off, I need to pick a point of reference. It could be either the 22.5-degree angle or the 67.5-degree angle. Either which way, remember, and I'm not going into detail, that the internal angles of any triangle need to add up to be 180 degrees. So here is a 90, 67.5, 22.5-degree triangle, the right angle triangle. This is calculable. I picked 22.5 for my point of reference and I'm sticking to it. In relation to this point of reference, the base, which is now 2.5, is the opposite side, and the height, that's not hypotenuse, okay, that's just leave it height, that's the adjacent side. And the only trigonometric function that has opposite and adjacent in it is the tangent function, so I'm going to use the tangent function. And in the tangent function, if you remember your high school memory jogger, soka, toa, tangent of any angle equals opposite. I'm going to change color on that one. I'm going to go blue on that one, because opposite over adjacent. Opposite over adjacent, and we know that the opposite side is the 2.5. That's going to be the 2.5, and the adjacent side, that's to be calculated. That's going to be the height of the triangle. This 2.5 is the base. So instead of O and A, I'm going to go with B and H. Okay, base and height. So to solve this one for height, and I'm not going to do a course on solving equations, but to get this one done, height equals base divided by the tangent 22.5 degree. Which, when you do the numbers and substitute in the 2.5 here, and you divide it by tangent 22.5 degrees. Let's just do it on a calculator. It's gonna be, let's see, that's too many decimals. That's 2.5 divided by tangent 22.5. On your calculator you might need to bracket this one and do 22.5 first and tangent after, whatever. That's different calculators have different circuitry. The height is 6.03 plus change because there's more digits to it. I'm just gonna go 6.0355. That's enough numbers for now. That's the height of this triangle here. There, 2.5 there, and for height 6.03. To get the area of the octagon, we have to plug in the individual sides of the triangle and multiply it by 16 because we have 16 of them. So I left the height of the triangle on the display intentionally. To get the area of the whole octagon, you need to multiply the height by the base again. So it's times 2.5 equals a number divided by 2 equals another number, don't worry about it, times it by 16, and that's when you get the area of the full octagon there, 120.71. Well, I already wrote that one up, but there's more digits to it, so that's why I'm just showing you the rest of the digits. So that's 120.71. Let's go back to the original slide. We got 120.7 with no other digits. That's kind of close, but this one is a little more accurate and there's more to it. Again, we're discussing what is the meaning of that 4.828 that we started with in the beginning, and it's coming forth now pretty rapidly here. So what we did again, we took the base and the height, times them together, divide by 2 and times by 16, but instead of dividing by 2 and timesing by 16, we might as well just not divide by 2 and instead just times by 8. So that's what I wrote up here. We had the base, we had the height that we calculated with the tangent, and then there is the times 8. And one more equation down here, I have the same thing. Instead of height, I plopped here in the 2.5 divided by tangent 22.5. It's still the same thing, and that base was 2.5. So if I multiply 2.5 by 2.5 by 8, I'm going to get 50 out of it. So that's pretty much the shortest way to calculate the area of that octagon that we started with. And again, I get the same number, 120.71 whatever. And okay, where is the 4.828? It's here. You take this number, 120.71, you divide it by the side length of the octagon squared. So I'm gonna divide this by 25 equals 4.828, and there's the rest of the digits. What the meaning of this 4.828 is that the area of the octagon is 4.828 times bigger than the square of the length of its side. If you want to recall this number rapidly from the calculator, what you can do is, instead of using 5 in it, if the side length of the octagon is 1, then this is what you can do. 2 times tangent 67.5 degrees is going to get you that number right away, or 2 divided by tangent 22.5, the one that we did. And like I said, if the side length of the octagon is 1, then that's not 2.5 already on a number, it's going to be a 2, and you're going to get that 4.828 right away. Again, the meaning of this 4.828 is that if you have an octagon, let me just get you an octagon here, thereabouts. The octagon, just move it there, whoop. There, just the octagon. The area of the octagon is 4.828 times bigger than the square of its side. So if you make a square there, that square will be 4.828 times smaller than the whole area of the big octagon. So that's what it means.